Fortunately, it was not one of those meetings I can just leave, so anyway.
We just figured you'd draw such a crowd that we leave space for people to come in and sit.
Okay, well, good.
He's a professor.
Here are the
Can't
bars.
stay that way.
I don't know if we'll draw a crowd or not, but anyway, welcome.
Everybody.
Welcome. I don't know if we've met. My name is
Yes,
Doug.
we have some issues.
Paul?
Kate.
Kate? Okay. Well, should we have a round of introductions since is this your first time here, or
I've been to another meeting.
been to another meeting? Okay. Should we take a round of introductions?
Yeah, we could
here
do that
just
real
for
quick,
the
just for make
sake
sure we
of,
all know who we are.
completeness. So my name is Doug Gooding.
Randy Whitney.
Janelle Bogart.
Toby Kessler.
Kay and Paul Kyle.
Dave Comer with treasurer.
Gary Hug.
Russell
somewhat
Van-
long-term.
Fisher.
Russell Valentine.
Okay. Well, again, welcome everybody. Today is the equinox. In fact, it'll be what? Exactly an hour, 59 minutes and 20 seconds from now. So I don't know. To me, that's always exciting. For some weird reason, maybe it's some deep memory of past events or something. But equinoxes and solstices are always interesting days for me. So we'll have a presentation a little bit about that later on. But I guess I thought we would start off with, as we often do, with sort of announcements, club news, things of that nature. Gary, you want to catch us up on the Tombaugh?
I sent around to the board at least. I got a response from our mirror maker, Gordon Waite, and he said that he has now sent the mirror to the coders, and the coders are ready to accept it. And by that I think he meant that they were waiting for it and they were going to do it right away. So we had an opening, so to speak. So hopefully I'll be gone all next week, starting Sunday. But when I get back, should be within that week that we'll get the mirror in. So
Yeah, and you're
kind of good news, and we'll wait and see if it's all true.
Well, considering the history on this, I guess I would not
Yeah,
bet the ranch.
don't
but,
put a whole lot on it,
Yeah.
but good chance that we'll get it in a couple of weeks.
Good. And it sounded like there were some people that were sort of interested in helping with all of that. I personally am. I hope I can make it out there. My time sometimes gets...
Well, I did hear from Justin. He's applying for leave for that week.
I thought that, yeah. He's going to apply for leave, so he's going to be available. So should be some helping hands. I certainly hope I'm able to make that. And I'm not... What we're talking about here is the mirror of our club's large telescope, which maybe you're familiar with, so just in case. And so that'll be pretty exciting. Mark Weiss was not able to come over tonight. In fact, I haven't heard from him in a couple of days. I think he's doing okay, but he gets buried in things too. But we finally got started on building the low spec. We're working on building a spectrometer. So we have actually attached parts to parts and run into things that we don't know how to do. So. So at least the project is, after long last, and a lot of people, and Gary and Russ, all kind of supplying parts and buying parts. And there's one more thing we have to buy for it. We've got to buy a slit wheel, which they're not very expensive. They're like 23 euros.
Okay, gotcha.
Yeah, they're like 23 euros or something, so they're pretty inexpensive. So I need to order one of those. But so fingers crossed, we'll get.
So these days, about $23, it sounds like.
Yeah. Although these days, considering the rate at which my investment portfolio is disappearing, I may not have $23. Anyway,
think of it as not disappearing, but just at a low point in your return.
Well, that's what they tell me, when in doubt, zero. So. But anyway, so my hope is that we're going to get that thing at least in. I'm sure it'll have a lot of calibration issues and alignment issues and all kinds of things. But
What is it that you're going to be using that for?
well, probably we're going to be using it to take. Well, again, this is dependent on getting a telescope to put it on, which it could be going online. We probably there is a real need for taking spectra of BE type stars. They're a kind of a cool star.
Very much in the red zone.
And they are kind of unusual among stars in that they're cool enough to actually have molecules form in their atmosphere, which most stars are too hot for that. So, and there's not a whole lot of data on them. So there's a network of people who measure spectra from BE stars, and that's one possibility.
AVSO's got a big section for that.
And another possibility is that there's a monitoring of some of the, I believe the Jovian and Saturnian moons for clouds. So they just need kind of long series of observations, and of course professional scopes tend to be kind of meted out on 2 or 3 days at a time. So there's some possibilities there as well. But
What wavelength do you use on those BEs?
the Bs, they're fairly cool stars. I think you kind of start getting into the red and even in a little of the near infrared, where they, of course, I can't remember. They peak at about. Well, I could figure it out. But they peak at about
60 something, 61 maybe.
probably a
Maybe
little
more.
bit shorter than that, but not too
Yeah.
much. So yeah, and the grading we ordered for the spectrometer is sufficiently blazed and ruled to get into that part of the spectrum. And it's it's not super high resolution, but we're building this thing for $300. And, if we had 300,000,
And the important part of this is that for us at least, we're so low in the atmosphere that our blues and ultraviolets are pretty extinct by the time they get to us.
Yeah,
So it's better if we work in that kind of a ready zone.
yeah, yeah. That's definitely true. And it'll be, spectroscopy is a little different even than, certainly different than image collection like the Center for Photometry or for astrometry. And even different from photometry in that, it's like instead of trying to catch a big bucket of light, that you're trying to catch little pieces of it so that,
Very
long
narrow
story short.
bands and,
long story short, you can't really, with a equipment like we have, you can't analyze anything that's very dim. So you're limited to probably about 6 magnitude stars, so 6, 7 maybe. So there are things you could see with the naked eye.
Kind of magnitudes of looking at the BEs.
There are 6 or 7 probably. It's about as good as we can do, especially since they're kind of dim reddish stars, so that they don't shine too brightly. So there's not a huge number of them, but there's a continual need for recollection of them. So, and every once in a while you'll see like AVHO, which Gary mentioned, will make an announcement that hey, we need spectra from such and such a star. And people point out. So it should provide another avenue for us to do some work out of Farpoint or elsewhere if we need to.
Of late, there's also called to support Hubble and what was the other one that was just recent? I can't remember what it was, but one of the other spacecraft that was monitoring things.
Yeah, the
And I-
Spitzer.
Was it
Is it the
Switzer?
Spitzer?
Yeah, maybe.
Spitzer's infrared, right?
Yeah,
Yeah.
well, in the area of infrared.
Well, yeah.
I mean, it can go to red, I'm sure.
Okay.
Yeah. Anyway, so that's like I said, we've not made a lot of progress, but at least we got started.
Yeah, something. I'll make
Other announcements? Anything?
I sent this out to, I think, many board members, but we're having a large group scheduled at Farpoint on October 1st. And that's one of the things we do. This is a school group, and they've been coming out for years. It's the high point of their year, and I hear that every time. And I've actually heard from some other schools, but they're going to put them off till spring.
Is that the Care Parallel?
The Care Farewell is coming.
And that's
Sadly, I'll
October
miss that one.
Yeah.
That's
Yeah.
October 1.
It's what we do is I schedule the first,
No, really?
and then if it's clouded out, I think the 15th.
Okay. Laura said she might like it. She likes doing it for the kids, so,
Yes, I know, these are third graders.
yeah, and she'd be good at that.
And the neat thing about this is they've already memorized the 20 brightest stars for the book of Earth. They've already studied all this
That's
stuff.
better than I've done.
I mean, you know, they're serious about this. And I have it scheduled so
And they come with a lot of parents.
they
Yeah.
come with a lot of parents, they come with little brothers and sisters, and sometimes they come with snacks, which is also a nice thing. The other thing too is we've had trouble with, you know, weekends and staffing and whatever like that. But if it's on the first, we will have something of a moon.
Okay.
And I don't think they've ever been there when we had the moon visible. So we can do some just letting them look at that. I sent that one 4-minute thing out to the board
Okay.
about
So,
that.
yeah.
Just a
And
day or
it's-
two ahead of first quarter.
Yeah, it's a couple days ahead, yeah. But I just checked sun, you know, when it's setting, set times for sun and moon, and it should work out right. But that'll be kind of a different thing to do. And then, you know, when we have a school group out, I always ask the teacher, you know, what emphasis is it? But they've already studied so much stuff, they just want to see it. And then they'll also get a couple planets, which will be neat, because that doesn't always happen, so.
Cool.
And if it's not on the first, then it'll be on the 15th.
And what
so.
day of the week is the first?
It's Saturday.
Saturday.
We do them on Saturdays, yeah.
Okay. That's-
Fridays, a lot of times there's school events,
Okay.
so you definitely don't want to try to park when there's football.
So what's the plan with all those kids? I mean, what are we doing?
Well, we usually break them into groups.
What are the groups?
Yeah, we'll break them into like 2 groups, and then, you know, I let the teacher kind of run that part of it, and we'll break it into a couple of groups, and then one group will go in and you know, kind of look at the tombaugh here and hear about that, all that, you know, the asteroid work, and a little explanation, just kind of an indoor thing, while the others are out there looking at stuff. And that's where we set up several telescopes. And like I said, this time if we do the moon, then that's going to be like it's like mine. A lot
Who's
of it.
bringing telescopes?
Hmm?
Who's bringing telescopes?
Right now, I think the only one we've got is, well, Justin. And Russ usually does a 12-inch, that's his territory. And then I'll have mine. And then I do the green laser thingy too, you know, that I do it. And I may just have Justin have him set up with the moon. Since we have moon, you know, a little bit of moon there, and then I may do it too. Probably talk more about that than usual. And I got to check with the teacher and see what they've done with that.
And then, of course, Saturn and Jupiter are going to be fun.
Saturn and Jupiter are going to be up too. Yeah.
So, how long is a Tombaugh asteroid presentation?
Well, usually he'll do that. Well, Gary usually does it, but it'll be that. And then also talking about just Farpoint in general and the niche
So
out
Gary's not
stuff.
there,
I know he's
so I'm
there.
thinking that's me.
Well, you know,
So-
now that you mention it, thank you for volunteering.
Well, I don't go out to Colorado until around the 25th.
Mm-hmm.
So
Okay. Mm-hmm.
I have not done a Terra Parabella group.
Okay.
So
The other thing too, which I just thought of with Russ, is we can put things on the screen.
yes,
Yeah.
are is that what you're expecting as a presentation from me? Or?
No. No. We will, I will, I always have to have the techno nerd do the stuff for me, but I've got enough stuff. We'll do the tombaugh, and then I may need to do pictures for that, but I think I've got them in the archive, which is at my computer. And then, I'll probably put something up there and do something about asteroids, and, you know, the you know, meteor crater and all that kind of stuff. And I'll put something together, and since you're not here, I'll make sure you get it. I will have to start on that as soon as I.
One of the pictures that I recently saw was a huge block of steel that got hit by a speck of like a small rock,
Uh-huh.
and it was going at such tremendous speeds when they shot that. It just pulverized and
Is that the JPL's high-speed rifle?
I'd have to look at it again, but I saw
Yeah.
that because you always do the quarter thing, but
Uh-huh,
this
uh-huh,
was
uh-huh.
such a huge example of how
Yeah.
speed
Mhm.
is more important almost,
Mhm.
then
That's what makes it dangerous.
that such
yeah.
a small particle did such damage to a huge metal block.
Yeah, well, if you want to send me
Velocity
that
squared.
picture, I'll put
So,
it in there.
Okay,
Yeah, and then, you know the thing with the quarter, you know how to do that, right?
I can do the quarter thing if I have to.
I can,
It's famous now.
it's
I don't know
famous.
if I have a quarter, but I'll try to
Well,
find
that's
it.
why I was having a problem.
Yeah.
Now,
Yeah, and
I
sometimes he even gives it back.
we can get some,
No,
get a,
Mhm.
get a little cardboard box with some sand or something to kind of demonstrate some things.
Mhm.
Yeah.
Well, you just bring
Yeah,
it
good
down.
idea.
Yeah, I can do that.
Yeah, that might not be.
So, okay,
But yeah, I figure,
and what time is it, are you meeting me there?
well, she hasn't told us either gonna be 7 or 7:30.
Okay,
I
and
went
then
back.
cloudy, the next
If
day
it's
is-
cloudy, I let her know, I have to let her know by Friday so she can tell the kids. And then our cloud day is the 15th. We do them on Saturdays, since it's school kids. Yeah,
This month?
yes, October, well, October, what month?
So, October Saturdays are pretty full,
Mm-hmm,
Mhm.
well, it's all right.
because the members' night's not up there.
Yeah, I was gonna say, these are the upcoming events, next general meeting's the 27th,
Mhm.
next public night, the 28th. When is the next
I
meeting?
think it's
I think
19th.
it's the Saturday before
Yeah,
public night.
So it would be,
Secure the mirror.
the 22nd?
I haven't done that.
Yeah, I mean, there's one this
Yeah.
Saturday too.
There's one this Saturday?
Mhm.
no, that's member,
Lock it up in
member
place.
this weekend.
Yeah, that's what kind of what we're talking about, though.
Oh, I thought you were talking about. Yeah, member night is this weekend, and I don't know if I'm gonna make it either.
Yeah,
I'm
I-
hoping.
this weekend,
Member night is so we can just.
Member
go out
night's
there
this
and harass each
weekend.
other.
gotta write a
Hmm?
proposal.
Yeah, this weekend,
Mhm.
and since most of the boards here, that table at Farpoint that had a bunch of those smaller things from the telescope donation, I'm gonna send an email out, like last time,
Mhm.
and get some of that stuff sold.
Mhm. Okay.
And if people wanna come out at members night, they can pick it up or look at it then.
Mhm.
But because this time I'm gonna send an email that says, this is the time I'm sending the email,
Mhm.
and then send that email, because it's like a swarm, and some people didn't understand how to reserve some of these items,
Mhm.
and then they kinda got a little.
Oh, yeah, and I was gonna say, I think we've got some kind of generic things like mugs or books or
So,
something.
yeah, there's not a lot there. There's a lot of diagonals,
Yeah.
a few eyepiece, several eyepieces that are not name brand or anything, but it'll probably pull in a couple of hundred.
Mhm. Well, I was gonna say, I know there was that one coffee cup out there, and something generic, so I figure maybe we'll take that to the Christmas party, you know. and
Well, I was
draw names or
thinking,
something.
there's some things out there that maybe we can do with Care Parabellum. You just take it. There's an unopened planetarium constellation thing.
Software thing, yeah.
It's
yeah.
a little plastic thing you said.
Yeah.
I mean, we just give that stuff away,
Mhm. And give it to the teacher.
or give it to the teacher.
Mhm. Give it to the teacher, and if she doesn't want it, she can find somebody who will
Right.
use it. Yeah, cool. That's a
Start
good
cleaning
idea.
this stuff out.
But yeah,
And
just
then
some of
if
that
it's
generic stuff.
okay with you guys, I don't need to ramble on. If it's okay with you guys, the telescopes that haven't sold yet,
Mhm.
I'd like to reduce the price on those. If
Yeah.
not, we are going to be stuck out there with a bunch of.
Do we, are most of them those little small go-to
Well, we got the
scopes?
big Canon that no
The big
one's
Canon.
bought, and then there are some nicer, smaller refractors
Mhm.
that'll come in handy when the solar eclipse hit, I think.
Yeah. Were
I'm
we,
surprised nobody has gotten them. I think it's mostly because there's no mount with them.
were we setting one of those aside to be a guide scope or something?
I've
He's already
already
got the
got
guide
it.
You already
scope.
got that? Okay.
But reduce them a little bit to see if we can get rid of them, because I'd rather
Makes
not
sense.
try to sell them on cloudy nights and ship them.
Mhm.
Mhm.
If anybody, I mean, to me, that's
Kind of thing. Okay, so, any other kind of announcements, stuff about upcoming events or anything?
It's good. Look, forecast says really clear nights
Yeah,
for a whole next week.
Yeah, this weekend. is
Yes,
supposed to be
because I'm
really
gone.
Oh, on a
Yeah.
new moon.
Yeah.
Also.
nice. That is just the nature.
Well, thanks, Gary. I hope to take advantage.
That'll be in my
Yeah,
divorce,
you do it.
in my divorce proceedings. That'll be,
That's just nature's way of taunting you. Well, anyway, so news. Again, these are always the news things I think are interesting, so I hope you do too. As ever, if you have news items during the course of the month and you want to include them, please send me. But this is stuff I thought was cool. First of all, this is the thing I think is about the coolest of all the things.
We
that's
better
gonna
hope
happen
this
week.
works.
This is something that's been in the works for a while now, the double asteroid redirection test. The idea on this is that it's this two asteroid system. There's a big one called Didymus or something and a small one called Dimorphos. And the idea behind this is they're going to ram a satellite into it or ram a space probe into it just to see how it moves.
into the satellite of the two.
Yeah,
Yeah,
into
smaller.
Dimorphos, into the
Smaller.
smaller one.
Uh-huh.
And the idea then is to it's all in kind of service of this idea that eventually we need to figure out how to redirect asteroids so in case one's coming at us we can move it just enough to make it miss.
Mhm.
So this is actually kind of an interesting test, basically.
Be interesting to see if it knocks it out of orbit.
Yeah, or does something or anything.
Move
You
it
know.
at all,
It's
yeah.
it's kind of an interesting probe, actually. I was just reading some of the technical literature on it last night, and it actually has a lot of advanced features. It has very advanced solar panels that are much more efficient than anything that's ever been sent out. It has very advanced propulsion technology. It's got an ion motor on it, right? And it has one really cheap, low-tech camera because they're and it's
All it
it's
needs to
very
do
massive.
is find out where it's
All
going
it's
to
got to
hit.
do is where to aim,
Yeah, that's right.
and it's actually really massive for its size. It's very dense because it's like a big hammer, right? There's some smacking in there. So anyway, the other cool thing, this is going to happen on Monday. The other cool thing about this is you can actually watch it. There's a live feed. So here's the YouTube video, YouTube link down here. And then it also had this other accompanying spacecraft. They were actually attached to each other when it was launched.
Oh, yes, it's
This
going to
one's
watch
been-
the whole
It's
thing.
been detached. It's like the watching thing, and that's how they're going to. And then there's another one, the Lucy or something like that. One of those
Yes.
probes.
Lucy is one that's going to the Jupiter Trojan,
But it's close enough that it's going to be able to image all this as well.
probably.
So anyway, this thing, Lycia Cube is what it's called. It's built in Italy, and it's going to be the streaming source on all this. So there's what Lycia Cube. It's a kind of a microsat or a nanosat or whatever they call them, sort of thing.
Actually, it's kind of a misnomer. It's not going to be live because it's going to be delayed by, what, 20
46
minutes?
minutes.
46?
Yeah, it's 46 light minutes away. So yeah, it won't be exactly live. But anyway, so if you are near a streaming source on Monday and you want to watch a satellite smash into something, which just seems so interesting to me, this is your chance. So this is what I thought was the most interesting.
In addendum to that, there was a program that was already paid for by Congress that is now in NASA, and because this one and there was something else that was coming up, they took out the NEO Surveyor,
Yeah.
which was one that I was particularly interested in, and they took that out.
Yeah, that was in the latest NASA. thing.
I'm just really upset.
Yeah, I saw that. It was a good budget.
It wasn't expensive.
But this thing got cut. And, that's the way these things work. Unfortunately, when you're dealing with, especially with big federal agencies, they would rather cut a whole bunch of little things.
Yes,
than one
rather
big
than
thing.
that, even it depended, and regardless of how good it could produce for the money, it didn't
Yeah.
matter.
I know I had an entire project taken right out from under me because it was a little project in a big
Yep.
project world.
Yep.
Mhm.
It's like the little fish get eaten. So,
Mhm.
but anyway, not to make this about
Not to
my-
bring up dead fish.
my
or anything.
grievances. But anyway, so this will happen on Monday, the 26th. So here's another thing I thought was kind of interesting. There's always been a debate about how galaxies form, and there was a theory. The theory has held for a long time that there had to be kind of a nucleus of very old stars near the center of the of the galaxy, and they found something very much like that. It's a population of very old stars, like 12.6 billion years, which were put in, formed very shortly after the whole thing got formed. And they were found by the Gaia satellite, which is one of the ones that we use.
I use
for
that all the time.
So it's done quite a service. But anyway, this was I thought kind of an interesting piece. This was one I also thought was pretty cool. There's been a debate for a long time about how continents in the proto-Earth form. So the idea has typically been, what happened was that at one time Earth had no continents, right? And the first continents were called cratons, and they still exist, actually. We were not that far from a epicratonic surface here, so like the Canadian Shield is a craton, and there's a few others, and they're like the oldest pieces of crust, right? They were the original crust. And there was never really an understanding about how exactly that happened, except they thought it had something to do with impacts, right? That penetrated the crust and caused it to form. And so some people, I believe at one of the Canadian universities, did a analysis of the age of cratons, and they found out that there was sort of a periodicity to craton formation. They formed about every 200 million years, and that's about the same schedule at which the Earth passes up and down through the plane of the galaxy. And when that happens, it produces gravitational forces that they think maybe increase the number of impacts. So it could be that the original continental structures were in some way related to this passage of the Earth up and down through the plane of the galaxy. It's been thought for a long time that it's had something to do at least with recent, geologically recent climate change, that there is a 200 million year signal in that as well. So, it's not a new idea that this would have some impact on Earth, but this is, no pun intended. But this was the first time I've ever seen this. So I thought this was a very interesting piece as well. And of course, the James Webb kind of continues to sort of knock things out of the park, probably performing better than anybody thought it would, which I personally think they always underestimate it, so that it's better than it really is. But still, it got a first direct spectrum. This is what's kind of cool about this, of an object orbiting a star, solar system. First direct spectrum of an exoplanet. So there's been inferential spectra for a long time, right, where you look at the spectrum of the entire star and kind of piece out the parts that are related to the exoplanet. That's kind of how astronomers have figured out things like composition of the atmospheres of some of these things. So now, they've seen some pretty interesting mixes of gases in these. But this was the first direct one. And so it was at 4.44 micrometers, I guess. So between about 4 and 15 micrometers. So that's that terminal region of the spectrum that the Webb is sensitive to. But again, this is it's pretty exciting because up to now, direct observations of these things were just not possible due to technological restrictions. Well, now there's possibility of at least capturing certain kinds of information. So another thing that the Webb did was it imaged Mars, which I guess I didn't realize that was even possible. But then I thought later, well, Mars is out past the orbit of it, so why not? But they actually, again, using these the near-infrared camera, which I don't know, back when I learned this stuff, 4.3 was not in near-infrared, but I guess it's a moving target. But anyway, they were actually able to do some some heat analysis of it. And what they found was that it has a heat distribution that's not all that dissimilar to the Earth, which is not a big surprise because it's also a circular object that's being illuminated by the Earth. But there were some compositional things in this Helix Basin in particular, this one that kind of showed up that thermally responded a little differently, so that gives you some clues about composition, right, about what it's made out of. And kind of also suggested, from what I understood, that maybe these big basins did have some sort of impact origin with them. So that was a kind of a neat finding from the web. And then Neptune in the rings, I thought this was very cool. You know, rings are always an interesting thing to me. And I never thought, you know, back in the day when I was learning astronomy, we didn't know Neptune had rings. And so apparently it does.
Yeah, and they had Triton. I saw an image where they had Triton in it, with a view of it.
Mm-hmm.
And it was,
Yeah.
yeah.
Well, and it's kind of led to some increased interest, I guess. I've been seeing more stuff lately about rings, and I should have showed the one with, you know, they've gone back and done a reanalysis of Saturn and figured that maybe one of the origins of the rings was a planet or a moon that got close enough to its Roche to be torn apart. Basically, you know, you get gravitational forces that can.
There's a big push now to send another spacecraft to Uranus and Neptune.
Just for that, just to kind of see.
I think, yeah, to kind of complement now what Webb's been picking up.
Yeah.
I don't know. It sounds like it's you know, it's a big deal because it's a big investment, and so
Mhm.
therefore it's a,
Yeah. Well, you know,
it's a big showy thing.
Yeah.
back
And I
when,
saw an image where they had done Uranus, and you could see, kind of like this, when you see the different, you know, kind of blotches. Of course, Uranus is just so plain.
Yeah.
And they were picking up detail on it from the web, so that was something different.
Yeah. Well, I do hope they get some probes out there. I you know, I find these things interesting. But I remember back very early in my career spending a little time working for NASA, and those days the NASA motto was cheaper, faster, better.
Yeah.
And there was a poster on pretty much everyone's door that said cheaper, faster, better, choose two. and unfortunately, a lot of the cheaper, faster, betters ended up not working because they were cheaper and not better. But anyway, so yeah, I hope that they're able to do this. But again, this is just a really and look how much it glows. You know, there must be some heat source in there, at least in the thermal
That's an
part.
infrared image.
Yeah. So I mean, Jupiter emits more energy than it receives, and it emits in the infrared. Neptune I thought was more icy or something. But maybe
Well, it's icy on surface, but I'll bet the interior is still pretty hot.
yeah.
Well, they've got, you know, they measured the winds on Neptune. It's just been phenomenal. There's got to be something doing that.
Yeah.
And you could see the storms and stuff in the back
Yeah.
of the Voyager.
Anyway, so I thought that was it.
It's just the further out Jupiter, smaller. But
Yeah. Anyway, this was one I sort of caught my attention. This is from the Los Angeles Times, and you know, Los Angeles being a city that I think does a reasonably good job of trying to manage its environment, installed a type of light that uses a lot less energy, right? Well, unfortunately, it produces glow in a part of the spectrum that is really bad for light pollution.
well, part of the reason is that it sends it out in all wavelengths, and so you can't even block it out with filters.
Yeah.
Mhm.
I know the Mount Palomar. My sister lived in San Diego for years. In fact, she just moved back to the San Diego area, and she remembers back in the '80s, the Mount Palomar astronomers had come down and practically begged the people to put hoods over the streetlights.
Yeah.
And they wouldn't do it. People were like, "No, it'll
Yeah.
take away from the bright city
The
lights."
bright glare ambience.
And it's gotten
Yes.
worse since then, obviously.
Mhm.
You know, I mean, the Mount Wilson Observatory is probably essentially unusable at night because of Los Angeles sky glow for almost anything. So it's unfortunate, but you know, I think we're still pretty lucky here that we at least have a few dark skies. Although, unfortunately, we kind of were facing that problem.
Oh, right.
All fields. Anyway, so you know, since light pollution was on my mind, that's when Okay, so that's my news highlights for the month. There's stuff
It's kind of a newsreel thing.
yeah. News of the world. So the night sky highlights. I think it's kind of coming into a good time as far as the night sky goes. I'm actually kind of happy about this because I like the fall and winter skies the best. So this is some of the stuff. I found this Universe to Go site here, my personal planetarium, and it actually has this kind of interesting diagram that sort of shows the sorts of things that you're going to see. So, you know, it kind of shows it in terms of what the moon's going to be doing. So there's the phases of the moon through the fall months, the autumn months. What the planets, so like, Venus will be visible in the morning sky through much of September. Mars is going to be visible late at night through the end of September, and then starting in October, I think it's going to be visible much more.
Yeah.
Jupiter visible all night, visible all night.
I think it's
much of the
either
fall.
at or right at, real close.
It's close to opposition, actually.
Yeah, a few days.
So anyway, this was kind of, and then it also showed the Orionids, which are meteor. So anyway,
Mhm.
same day as the crash, Jupiter will be at opposite. So you can have a double header. You can watch the dark things smash into the asteroid during the day, and then go out and see Jupiter. Jupiter will be at opposition, which is kind of this geometrically similar to what the moon is during a full moon. So you get full illumination, and it's closer, I think.
Plus, it's pretty high up
And
for us,
high.
which is really nice.
So this would be a really good night to see Jupiter. It's also on the 8th is the western elongation of Mercury. So if you're one of those people like me that has never seen Mercury, you might get a better chance. So this what the elongation means is that it's at its furthest point. Basically, there's a western and eastern elongation, and it's I think you can it'll only look like a half
It crescents, yeah.
crescent, but it's the easiest time to see it. And so this is kind of what it'll look like in early October mornings. And you got to get up in the morning to see it. Mercury never gets very high above the horizon, so
About 10 degrees max.
yeah. So if you kind of look at Regulus, look east, kind of go down and a little bit to the north, I guess it would be, you might be able to see it. Of course, it won't look like this. This is what it would look like.
I always thought that Mercury looked kind of like a gooseberry. I don't know if anybody even knows what gooseberries are anymore.
I always,
The lines there and stuff, that's kind of.
No, it's the stuff that goes into pies.
Yes, that's right.
I always thought it was a fairly drab-looking planet.
Mm.
I'm sure there are those who disagree. So anyway, this would be a good time to see Mercury if you've never seen it, which I never have, but I probably
One of the first things I did when I got my scope, got up in the morning and I had Mercury and Venus, beautiful little crescents right
Yeah.
next to each other.
Well, one of these days maybe, but I don't know.
That's before the trees.
And of course the Orionids. The Orionids are actually former pieces of Comet Halley. That and it's a kind of a moderate, I guess, meteor shower. It's not one of the more intense ones, but it's. I guess the reason why I kind of like it is that it is from Orion, and it kind of signals the fact that now my favorite constellation is now starting to be visible again. And soon it'll sort of dominate the lunar skies, which is my favorite time of the sky. So if you want to see those, you kind of look for the club, and the radiant is pretty much right there next to it.
What's the other meteor shower that's from Halley?
There's a moon.
It's like
Is it Lyrids? Are Lyrids?
I don't remember.
Wasn't it on the previous slide?
I think it was one of the small ones, huh?
There.
No, it's one of the
The
small ones.
Leonids
I don't
are.
think it's
Leonids are
It's a fairly.
At, Aquarids.
Shower.
in there.
It's like in spring, kind of
I think.
opposite.
The
Anyway.
Leonids are from
At Aquarids.
at Aquarids.
Are the other ones from Halley?
Oh,
Yeah.
there you
Are
go.
the Leonids the one that are actually an asteroid remnant and not a comet? I know there's one.
Yeah, that's oh gosh, I can't think of what it's called, but yeah, it's a
Phaeton or something came from.
it's an asteroid that may have been a comet at one time, but
Oh,
has lost all
yeah,
its
yeah.
volatiles, and we've never seen it with volatiles.
Okay.
So
Anyway, so if you look out, you kind of need to look off to the sort of southeast here, I guess, to see this, and you should be able to see it sort of later in October. If you're looking at deep sky stuff, there's some kind of interesting galaxies. This is one that I think is pretty interesting because you see the dust in so well on it. The Helix Nebula is going to be visible. The Eye of Sauron, we call it sometimes. If you mess around with the colors, you can really make it, like Photoshop it. You can really make it look like the Eye of Sauron. But, that's another one that'll be visible. This is my favorite galaxy. I think we had this one the other night at the putting night, didn't we?
51.
It's M51 and then NGC 5195 is the smaller one. And they call this one the Whirlpool. And I guess there is actually, I've heard debate about whether they're actually connected by.
Oh, yes, that's been settled long ago. There is a connection
Okay.
between the two, and it's very obvious under long photographs.
Okay, all right.
Um,
Yeah.
And the smaller one is actually pulling material away from the big one because the smaller one is actually more condensed, more is heavy.
Denser, yeah.
Yeah.
Well, there was a debate, I mean, years
More
and years
mass.
ago that it ended up kind of running a friendship between
Yes, yes.
the guy that
Which is really stupid.
Sandage.
Art.
Sand-
Wasn't Art
and
involved there?
Sandage. Yeah, Art
Yeah.
and Sandage. They were these good buddies, and then ended up practically hating each other over the fact that
Yes.
they disagreed about how close these things were together and whether
Yes,
they were
and
connected.
who was it? It was it Art that said they were close together, and the other guy said it was
and their
further
redshifts were
further
different.
distant, and
Yeah.
therefore wasn't connected.
Yeah, and and that was not the only thing apparently that these guys disagreed on. But so anyway, I guess Sandage, I think, passed away not too long ago. Apparently they reconciled later and kind of decided that they didn't need each other after all.
Wouldn't it be amazing if the matter that's going into the smaller one included a planet with beams on it? And the change, I mean, imagine what happened to Earth if it started getting sucked away by a huge gravitational, I mean, it would
Yeah.
change everything for us.
Well, I
You
don't
know,
know if
I-
you'd even notice it though, really.
I'm sure
Yeah, we would.
there's some theory that would reconcile what you're talking
Is
about.
it, I've seen these images of colliding galaxies, and you got one go, and they say there's
Yeah.
the material in them is so sparse that nothing will hit.
Right.
And that nothing touches each other as they
Yeah.
pass through. It's like going through two sieves.
Yeah.
But you think something would have to have changed. Got stars getting closer together.
Well, there's gravitational
Yeah.
influences that affect the mass and the dust, and that's true. But because of the numbers of figure 100 billion suns, and they pass through each other without ever, not a very strong chance that any two stars will hit.
Yeah, but if we all of a sudden, a million years from now, had another sun in our day,
Well,
it would change everything.
Yeah, what was that movie?
That's true.
They turned Jupiter into one. The thing is though, and the other thing, and you see it in some of these, is they're getting close and whatever, gravity starts pulling it all over everywhere, but there's just too much space, so it won't be close.
The difference between back in, a couple hundred years ago and now is that we have the visualization that the universe isn't a peaceful place.
No.
This is true, yes.
Yeah. In fact, one of the first popular books anybody ever gave me on astronomy was called The Violent Universe.
Yeah.
It was I think it was a National Geographic book or something.
Yeah.
Anyway.
Mhm.
So another good galaxy you can kind of see in the month of October is Bodhi's galaxy. It's really big. That's one that's kind of
Makes a nice photograph.
It's the only galaxy I've ever successfully photographed.
Oh, you can
I thought
see
I'd
that
throw that
one
one
even
in.
dark sky, you
Yeah.
can see it just,
It's really big.
yeah.
But it's nice, kind of.
And it's up all the time.
So anyway, that's another one. That,
Yeah.
all right, so that's my observing highlights.
That's-
Good.
Isn't it interesting that they decided to call this Manhattan Hinge because of one city?
This is actually the Salk Institute.
Yeah, I know, but they refer to it kind of generally when they do this line it up, they call them a Manhattan Hinge,
Oh, really?
like.
Well, I've heard it. I hear them talking about the Scripps Hinge and stuff.
But that's not.
Mhm.
But that's not perfectly solstice yet.
Not quite. It's up
It's gonna go north of that one.
Yeah.
Mhm.
Anyway, this was actually taken on an equinox. So, but anyway, so I thought since we are what
Mhm.
17 minutes and 25 seconds away from the equinox, that this would be a good night to talk about solstices and equinoxes and the astronomy of Earth, basically. So my favorite planet is the Earth, so I like to talk about it whenever I can. And I also thought I'd talk a little bit about what some of the implications of all this, if you think about him as an astronomer and not just as a person on the Earth. So I thought I'd start with that. And of course, this is a very famous photo that's been around for a few years now. This is the Salk Institute in San Diego, and they built this kind of plaza on here with this fountain thing that aligns out to sea with the sunset on the day of either of the equinoxes. And it kind of became a very famous photo, and I've liked it very much. So anyway, as I said, the autumnal equinox is today. It's at 8:04, so I was sorry, I should have said 18 minutes, but now we're down to like 16. So, and it's the first day. What kind of marks it is it's the first day of astronomical fall or astronomical autumn. And I put astronomical on here because it's not necessarily climatic autumn, and those two things are usually separated by the climatic autumn is actually a moving target. It's defined by the date at which growing degree days pass below a certain threshold. But it is, from an astronomical point of view, the beginning of fall. So I thought that since we are interested in astronomy, we would look at the astronomy of all of this. And I wanted to back off, though, and provide an even bigger picture here, and why it is that solstices and equinoxes are the dates they are, and what's important to us here on Earth about these things. And so, much of my academic training is in climatology, so I always like to talk about that as well. So one of the easier ways to understand why it is that we have equinoxes and solstices and everything that happens in between, and why it matters, is to think about why it is that the Earth has a climate. And the first reason for it has basically to do with the fact that, the Earth is a ball, right? It's a sphere. And so if radiant energy arrives on it, it's going to be more concentrated in some areas than it is in others, right? If you want to do a little experiment, I was going to bring my globe and do this experiment, but unfortunately time got away from me. But if you do this sometime, take a globe and take a flashlight and shine it at the equator and then move it up and shine it at the, up around one of the poles, and what you'll see is the spot of light gets bigger as you're spreading it out over larger areas. So what that means is energy per unit of area goes down, and so temperatures are going to go down, right? So the Earth would have a climate regardless of its geometry, simply because of its shape. But what makes the Earth, and the other thing that kind of controls all this, of course, is the atmosphere that plays a role in scattering and distributing the solar energy. But if you don't have to, you don't have to live in the mid-latitudes like we do, though, to understand that we have a climate that varies on more than just latitude, right? That there's a seasonal component to it as well. And so understanding the seasonal component is really where you start getting into what the solstices and equinoxes and all that stuff are really all about. And so, we're all astronomers here. We know what the ecliptic is. We look at it mainly in the context of probably of finding planets, right? But what it kind of is if you extend it out the equatorial plane of the Earth out into the sky, that's what the ecliptic is, right? It's an extension of that. And it's also kind of helps us define the tilt of the Earth. So again, I didn't bring my globe with me, but I'm sure you've all seen globes in those little holder things, right? Mm-hmm. It's always shown as tilted, right? Well, the tilt is due to the fact that the Earth's rotational axis is tilted with respect to the plane of the ecliptic. It's actually tilted 23.45 degrees with respect to a line that's normal, that's at right angles to the ecliptic. And so that 23.45 or 23.5 kind of becomes important for understanding some of the things about things like equinoxes and solstices as well. So you kind of see that in this diagram, right? There's that 23.45 degree tilt there, 23.5 is what it usually is. And then also kind of begins to explain why we have seasons. So seasons are just then the result of the fact that the geometry of the Earth relative to the sun's incoming solar radiation is continually changing throughout the year. It changes latitudinally, but it also changes through time. So this is obviously a diagram that's not scale, but it kind of shows the orbit of the Earth around the Sun, one revolution around the Sun, right? The Sun revolves around the Earth, or the Earth revolves around the Sun, rotates on its axis. And you kind of see here why you get a real sense from this diagram of why there are seasons and what the solstices and equinoxes really are. So if you look at these little white lines on here, and unfortunately I don't have my gloves. I do this demonstration in my classes by putting a little star up on the ceiling and then having the students pass a globe around through the class while pointing the axis at the star. And that's the important thing, right? Because the Earth's rotational axis always points at the same point facing the sky, and that's where the North Star is in the northern hemisphere. That's why it's the North Star. So you kind of see these rotational axes all pointed in the same place. And what that means is that the inclination of the Earth relative to solar illumination continually changes through the year. In fact, the word climate is derived from the Greek word klima, which means inclined, right? And that's why that kind of reflects the fact that climate depends on this. And so what the solstices and the equinoxes then represent are kind of a set of inflection points, if you will, along this orbit. So I'll start with the solstices because, I'll start with the equinoxes because they're simpler and it's an equinox. So what the equinox situation is, so let me just kind of give you a bigger picture here to kind of show you. So the Earth's rotating on its axis, right? It's revolving around. Obviously, this is clearly not scale, but you kind of see how all those rotational axes are all pointed out in the same area. And by the way, we're only really going to think about seasons in the northern hemisphere because we're in the northern hemisphere. If you want to know the southern hemisphere, just reverse everything I say. So on the day of the solstice, then, the solstice, I guess I'm going to start with the solstice. On the day of the solstices, they represent the day of the year in which the inclination is either maximally towards the sun, in other words, the tilt is in the direction of the incoming solar radiation. That's the summer solstice in the northern hemisphere. And in the northern hemisphere, it happens by June the 22nd or 3rd or something like that. And then the winter solstice is the maximal inclination away. So the solstices are contrasts to one another, they're like bookends. So if we look at that here, this would be the summer solstice in the northern hemisphere. So you can see that inclination is 23.45 degrees roughly. And what that means is the northern hemisphere is kind of leaning into the solar radiation basically. So the solar radiation is arriving at a much more direct angle. On the day of the summer solstice, the northern tropic, which I can't remember, I can't keep my tropics straight. Cancer is the northern one. The sun will be directly overhead at noon on the day of the summer solstice, the only day of the year that the sun will be directly overhead there. If you're north of the north tropic or south of the south tropic, the sun will never be directly overhead. So you can see, I think this kind of explains why it's warmer, right, on the summer solstice, because you're getting much more direct energy and the days are longer too. If you went out and watched the sun go through the sky, it would rise much further to the south of the east, set further to the south and west, and be in the sky for a longer period of time. And you can kind of feel it too. You go outside on a summer day, right? The sun feels intense on you. Whereas you go outside on a sunny winter day, it just doesn't feel quite as hot. And that's because it's arriving on your skin at a much more direct angle. So this is what the summer solstice in the northern hemisphere looks like. This would be the winter solstice, kind of the opposite situation, right? Now the sun is much more directly illuminating the southern hemisphere. It's distributed much more, its distribution is much less concentrated in the northern hemisphere, and so it's colder. And once you get to the Arctic Circle, the sun doesn't rise. So it's the beginning, essentially, of a period of time in which the sun will not be above the horizon, if you're actually at the pole or anywhere north of the Arctic Circle. So that's what the solstices are. The equinoxes, then, are the kind of the balance points in between. So they are the day in which, here's the day in which the Earth's rotational axis is inclined maximally away from the sun, right? This is the day when it's inclined maximally towards the sun. And the equinoxes is the day when it is essentially perpendicular to the incoming solar radiation. If you think about the energies coming in these parallel streams, right? It's perpendicular. And you only need to look at one slide here because both equinoxes are the same. So there's two equinoxes. There's what's typically in the northern hemisphere called the spring equinox. I learned my climatology from a grumpy South African man. So I learned to call it the vernal equinox, which is the more common term in the southern hemisphere, which according to Dr. Plume was the superior hemisphere of the Earth in nearly every way. But anyway, so I developed that habit. And then, of course, the autumnal equinox is the one that occurs in it's the beginning of astronomical fall. So we're 6 minutes away, 5 minutes away. And so on this particular day, you do get symmetric distribution of the energy around the equator, right? If you were to go measure the energy with a device like a pyranometer, which is what you use to measure sunlight, if you could measure it at the same time across an entire transect of the Earth, you find it's symmetric, right? So that's what an equinox basically is. It's the day of the year when the Earth's rotational axis is perpendicular to incoming solar radiation at the time of the equinox, which, because of a variety of reasons, doesn't always happen at the same date or time. It's also the day when what's called the declination angle is 0. And you can kind of think of the declination angle as if you looked due east, for example, the declination angle is the angle away from due east to either the north or south that the sun comes over the horizon. It actually has a little bit more involved definition in that, but that's a pretty good sort of back of the envelope. So on the day of the equinoxes, it rises due east, so its declination angle is 0. And now we're headed into winter time, the low sun season, so the declination angles are going to start getting negative, right? They're going to start going towards the east. So here's kind of illustrates that. This is through a year and 2 years of time here. So we started here in December, the December solstice, the winter solstice. The sun rises maximally to the south of east. As you progress through the year, it gets steadily, marches steadily. There it is at the autumnal equinox. Now it's going to be due east or west if this is a sunset, I guess. I think this is a sunset, actually. And then you reach the summer solstice, and then we're back towards the winter solstice, and this would go continually on and on. And if you're, somebody who likes to get up in the morning and look at the sun, you'll notice that it comes through. Its rising and setting positions change.
The equinoxes are also the time when, since so many streets are laid up north, south, east, west, that like at sunset right now, you're looking right into that baby.
I live to the west of campus, and I drive to work along a street that's laid out due east, and I go in early enough to be looking right straight into the sun. And I realize how dirty my windshield really is. Dirty and pitted.
Yeah.
All right.
Well,
So
I had an occasion when I used to drop my kids off at school, and it was during the spring that it happened, and I had to drop them off and then, do a due east thing. You couldn't see the stoplight, you couldn't see anything because it was in there. And accidents do kind of go up at that time too.
Yeah.
Because it blinds you.
doesn't surprise me.
Mm-hmm.
So anyway, fun facts about equinoxes. Sun rises and sets due east and west. Rises due east and sets due west. If you happen to be at the equator on the day of an equinox, that's fine. No, that's right. At solar noon, at the point which the sun reaches its highest point in the sky, you'll be directly over here. So you go out and straight up, you'll be okay. Everywhere else, this is, if you ever want to know the angle that the sun is going to get above the horizon on the day of an equinox, all you got to do is subtract your latitude from 90. So our latitude here is roughly 39.15 or something like that. Subtract that from 90, and that's how high the sun got at solar noon today. Couldn't tell really because it's pretty high. By the way, any other day of the year, you can also calculate how high the sun is going to be by subtracting the latitude and that declination angle. So if you can measure that declination angle, if you know what it is, you can look it up in an almanac. You can figure out how high the sun is going to be above the horizon. And this was supposed to have a strike through here because there's this common, the equal is supposed to be crossed out here. It isn't. There's this kind of common myth that the day and night length is equal on the day of an equinox, and it's perpetuated by the fact that the word equinox means equal night, and that's not true actually. It's the reality is that day is a little longer than night, and the reason for that is that you get we all know, we're all sensitive to the fact that the sun sets and then it's not dark yet, right? You get this period of civil twilight and astronomical twilight and all that stuff. What's happening there, of course, is the atmosphere is kind of bending light over the visual horizon. So if we had no atmosphere, things really would be equal day, and of course we wouldn't be able to see it because we'd be dead. But
One minute.
one more minute. Should we have a moment of silence or something?
We gotta have a party.
Pops.
Pops.
Anybody bring a champagne? Anyway.
Oh, let me go see.
But anyway, so they're not equal. Contrary to widespread belief, day and night length is not equal. Day is a little bit longer, and it's because of
The day is always longer.
But it's the closest you can get. Okay, so there's a few fun facts about the
804.
Okay.
We made it.
If we brought an egg, we could see if it stands up, which
Which is
you know. Anyway, so day is a little longer because the atmosphere bends and scatters. That's making that. And so, why do we care about this stuff? There's a lot of reasons for caring about this stuff. I mean, there's purely scientific reasons, but people are interested in these things. I showed this picture because if you think back to that other one, which was, shot by a professional photographer with the place closed off, and you see it. But this is, if you went there on this day, this is what you would see: a bunch of people there who are, interested in the fact that you're going to see this phenomenon, right? And it kind of suggests that maybe we are a little bit more aware of the sky in ways that we don't necessarily think.
Or that we have a lot of bored people.
Or there's just people that don't have
Yeah,
anything to do.
on the news they always show the Manhattan Hinge thing and all these, streets in New York that they're taking a picture, kind of like that one, yeah.
But people have been keeping track of this stuff for a really long time, for a variety of different reasons. One of those is that, calendars, the way we think of it, is something that you can buy at the hardware store or whatever. They've only been around for all that long, and so if you wanted to keep time, you had to do it astronomically. Probably the first instance of applied astronomy was timekeeping, and timekeeping both on an annual scale and also on a daily scale. But here's an example from an annual scale. So this is Stonehenge, this monument in southern England that is at least at one level, it's basically a calendar. It has a bunch of stones that if you sight along them will show you the time and date, or show you the time at which the equinoxes occur and the solstices occur. And the people that built Stonehenge were farmers, and they really needed, this was not just we're doing this because it's cool. They, like the Salk Institute, I think, just did it in an architectural statement. This may have been an architectural statement. It certainly wouldn't have been a trivial thing to put together. But it was also really practically important because this kind of showed when to plant, when to harvest, when to have eventually certain rituals that were associated with planting and harvesting. So it probably played a real central role in the lives of these people, not in a ceremonial role as well as a kind of a practical role. So this is probably, I think, the best known of all these kind of ancient sun calendars, but there's a lot of others. This is the Bighorn medicine wheel. This is located in Wyoming. This is just one of many, many of these that are found mostly on the plains, built by Native Americans. Medicine wheel is a little bit of a misnomer. These were probably nothing to do really with healing. But they were similar to Stonehenge. They were sight lines for determining these critical days in the course of the year. You can kind of see that here, right? You can imagine if you stood here and looked out over this particular thing, that would have been lined up with probably one of the equinox sunrise conditions, right? And then the solstices would have been along these axes. And so you can kind of see how this might have served as a time measuring device. I thought, I was pretty sure I heard once that there was a medicine wheel in Kansas, but I've not been able to find it. There are a couple in northern Colorado. There's a bunch of them in like the Dakotas and some of the northern things. Anyway, so this is just another example of something that is kind of a practical use, but probably also had some ceremonial uses as well. This is one I actually had seen in person. This is what's called the sun dagger, the Anasazi sun dagger. So this is in Chaco Canyon, northern New Mexico. It's located on this formation called Fajada Butte, and what it was is an accident of geology. It just so happened that there were these stones that fell in such a way that when the light would shine in through them on various dates of the year, they would cast this little light dagger thing. And so the ancient people that lived here kind of put this spiral in here, and the pattern of the spiral kind of tells you what date it is. So the summer solstice, it bisects if that's a summer solstice. I couldn't find any equinox ones, so I put the solstice in there. But the fall equinox would fall here, the spring equinox kind of here, the winter solstice like so. This unfortunately does not work anymore. There was some seismic activity in this area that shifted these stones, and it's been that way for quite a while now. I think since the late 80s. It's no longer functioning. I actually got a chance to go see this thing one time. It's been off limits to the general public for quite a long period of time, but we had family friends who were in the National Park Service, and Chaco Canyon is a national park, so strings got pulled, and we got to climb Fajada Butte, which is nasty, nasty climb. It's loose, manky rock, very hard to protect. So it was not fun to climb, but it was really cool to see this, even though it wasn't on one of these days. Anyway, so that's another. But again, that's another example of probably both a practical and a ceremonial significance of these special days. Here's a place I've not been, but Machu Picchu is in Peru, I believe, or South.
It's Argentina, isn't
Argentina. Is it that far
It's a
south?
long one.
it? Yeah,
Chile?
Argentina.
Yeah.
Chile?
Chile. Is it
Yeah.
Chile?
Yeah.
It is Chile.
Yeah.
Okay.
Yeah.
Yeah.
It's-
Yeah.
yeah.
But anyway, it's this kind of ancient city. Has a lot of solar alignments built into it, but there's this one rock in particular that not sure I can give this justice. Intihuatana.
I was going to tell you wrong, yeah.
And it roughly means the place where the sun gets tied, and it has a significance, right? It's an aligned site. So this is yet another example from the ancient Americas. And there's dozens and dozens of these. The pyramids.
There's, I think it's the Maya, and they had stone, but they tracked the moon as well.
Mhm.
And it went, I mean, it was for multiple years. They said it's the most accurate thing ever done. And how
Yeah.
long ago
Well, they
was
spent
that?
they had a lot of time to watch. You know?
Yeah.
So the pyramids many pyramids have alignments here. This is the pyramid at Chichen Itza, which is in Mexico or Guatemala, and it has alignments that are directional and related to these solar points. This is the Cheops Pyramid, Great Pyramid Complex, and the alignment here is that if you're on the day of the equinox, the sun sets on the Sphinx's shoulder. So then they figured that was an intentional alignment. So these things are built, and we could literally go on and on about this. I actually took a class on archaeoastronomy, and we spent an entire semester talking about this stuff. And again, I think it points to the fact that there's more to this than just people wanting to know the date. There was a lot of ritual significance as well. So another thing about the equinox is that it's not always going to be the day that it is. In fact, it continually changes. And the reason for that is the way that the Earth kind of moves. Right? So if you could watch the Earth for a long period of time going around and on its axis and moving around, so it would look like it's wobbling a little bit, like a top. And that produces this thing, it's called the precessional motion, and that produces this precession of the equinoxes. So this is the circle through which the precessional motion goes. We're about here right now, so the North Star is Polaris. Polaris is the North Star, it's the pole star. As time goes, and we're kind of headed this way, right? So as time goes, the other stars will become essentially the North Star. And what that basically means is that the date of the equinox also has to move. And that kind of leads to another myth, right? So I don't know if you were around in the 60s, there was this. I was pretty young, but I definitely remember my sister having this record in which they would play the Age of Aquarius. Right? And it's the dawning of the Age of Aquarius. And it turns out this is mostly an astrological thing, so you take it with a little bit of a grain of salt. But there is actually a lot of debate about whether we're really in the Age of Aquarius now. And here's the deal, right? Right now, another way you can think about an equinox is it's the time when the sun passes below the plane of the ecliptic, going down, right? And it turns out that happens now when the sun is in Pisces. But it's starting to kind of move away. So here's Pisces right here. Here's where we are. So we're kind of getting out of Pisces and heading into a different constellation. So part of that, I'm not really sure why they came up with the Age of Aquarius, because shouldn't it be the Age of Aries? But anyway, there's a lot of debate amongst, interestingly enough, amongst astrologers about where the dividing line between continents are. So apparently there's one school of astrologers that think the Age of Aquarius is started in 2012. There's another one that said it started like 300 years ago, and then there's another group that's, no, it's 300 years away. I don't know. I guess I don't really feel like I have too much of a dog in that fight.
But the Age of the Fish just doesn't have a ring.
Yeah, it's the Age of Pisces. But apparently the Age of Aquarius was supposed to be this golden time in human with, what is it? Harmony and justice.
Symphony and
It hasn't really worked out that way.
Yeah. So if that's going to happen, I'm hoping that we get onto it, because, it seems like we are in the anything but age. Anyway, but it does sort of illustrate this idea that people have been paying attention to this stuff for a very long period of time and thinking about thinking about these astronomical events. So the equinox occurs when the equinox occurs. The autumnal equinox occurs when the sun is in Pisces, and the vernal equinox is. I should know this because that's where the declination, or that's where the right ascension system starts.
I thought that was Aries.
That's it. Maybe it is. Anyway,
The first point of Aries, isn't it?
I think that's right.
I don't remember.
Anyway, but this kind of relates this back to this stuff. So anyway, there's also a lot of cultural importance to equinoxes, which again, these significant dates probably attracted attention. So one of the ones is that it's in ancient Greek mythology, it's when Persephone returns to the underworld, right? Go meet up with her beau Hades, God of the underworld, right? So Persephone goes down into the underworld on the day of the autumnal equinox. So today Persephone finally gets to go see her love.
Well, her husband, I don't know what happened.
Yeah, I don't know. I would hope so. I would hope they have he did it out of love. Anyway, and obsession. But anyway, yeah, that's one of the cultural myths associated with the autumnal equinox. It's also the time of the Chinese Harvest Moon Festival. It doesn't occur exactly on the equinox, but it's very close to it. I think it's October. I think it's in October this year. But this is a cool festival. I've had a number of Chinese students over the years, and they have kind of clued me in on all this. And they make these paper lanterns and put like candles in them and let them float away, which looks like a fire hazard. But,
We used to have fireworks that did that.
But it's really kind of a striking sight to see these things. The group that I did, they were scientists and careful people, so they would tether these things so they couldn't get away, go start a forest fire or a grass fire somewhere. But they also make these things called moon cakes, which are pretty tasty. And according to Dong Lo, my most recent Chinese student, the only real moon cakes come from Harvard, which is where he's from. So he brought me one time. Really pretty tasty. So that was good. So that's one of the. This is a Japanese celebration, and it's a Buddhist thing, and it involves basically honoring ancestry and honoring ancestors. But they bake these special cakes and teas for this. So this is a Japanese, but it's an equinox. It's actually both equinoxes, fall and spring. This is one that kind of freaks me out. This is Mabon. And it turns out, I thought, this must be some ancient ritual. It's not. It actually came about relatively recent. It's kind of a pagan ritual, right? It's become quite popular amongst pagans and neo-pagans. Celebrations take place at Stonehenge, all these guys in white robes here are these neo-pagans. Involves oftentimes very elaborate kind of feast days and eating, kind of typical fall foods, because it's a harvest festival, right? So all the corns and apples and all the things that kind of ripen in the fall, pumpkins and that sort of thing. And if you want to go to a Mabon festival, there's one in 25th. That's this Sunday, right? So if you want to go, it's at 10:30 at Snyder's Cabin, which is where we have our Christmas thing.
10:30 p.m.
And
I thought they were.
I think that's part of the deal, right? Anyway, so if you really want to experience this with, I guess, the neo-pagan population and interested bystander population.
I don't know that I've got any robes or cloaks that would be
I
appropriate.
think I'm going to have something else to do at 10:30 on Sunday. Anyway, so this is one that it's relatively recent, but it does kind of reflect the fact that, solstice, one of the things that the equinox is really, that the autumnal equinox is really closely associated with is things like harvest festivals. And even Thanksgiving actually is in some ways kind of an echo of that, basically. All right, so the other thing about it is, that I like about it, is that it's time to kind of welcome my favorite skies. So it's the time of year when we welcome the fall and then the winter skies, which is my favorite time of year. So I'm looking forward to that. All right, so with that, I will cease talking.
You should do this forever.
You should do this professionally.
I'm sure my students will probably.
Elections are starting or are ongoing. No.
Oh, yeah.
The ballot will come out in October.
Anyway, so anybody got an idea for next meeting?
I could do how do you process planetary images? Yeah.
I would be very interested in that.
This would be how you use pip and AutoStacker.
Okay. Should we bring like computers and hands-on stuff, or?
Oh, sure.
I've got a few hundred Jupiter images you could have.
Yeah, I was planning on doing Jupiter. I was planning on taking Jupiter images during the members' night on Saturday.
There you go.
So if you wouldn't mind getting a title, not right away, but at some point, so I
Okay.
can kind of get it on the schedule and all that,
Sure.
And that way take him off the schedule.
and take me off the schedule.
You can still do the news thing.
Okay.
Oh, yeah.
Well, I figure, you know, you can probably want a break from me.
Yeah. I mean, it,
So,
We
it is
do, but
now,
not at the point of us doing it.
yeah. No.
it is now astronomical fall.
Yeah.
You've survived astronomical summer again. Well done. Congratulations.
Bring on the applesauce.